All right. Can you give me a screen share? Cool. So first of all, let's see. I think we're pretty much on Macs here, right? So for Windows, there is an installer that you can use for MakeCode, but you can also run it just in the browser. The only difference is if you have the Windows app, you can kind of see sensor feedback on a little graph. But since we're all on Mac, you can open your browser and go to makecode.adafruit.com, and that will get you to here. And I love that they've co-branded with Adventure Time. That just makes me happy. Cool. And who's been here for the previous classes with MakeCode with Helen? And I think Francesca and Darcy did some the past 2 days as well. Cool. Okay. So we'll start there, but I'm just going to go ahead and talk about LEDs in general for a little bit. These are the classic LEDs. This is the old school LED, the kind you see, as a power indicator on electronics. There's several different types. Most of them are through hole, which means if you were to, I don't think I brought a circuit board, but with through hole design, if you could give me a little, there we go. It's all right. We are all learning here. It's great. Well, anyway, you can see the leads here. Basically, the idea is if you were soldering this to a circuit board, is everybody familiar with soldering at this point? It's basically little tiny welding. It's great. If you were soldering this to a circuit board, you would feed these leads through the drilled holes in the board and then solder them into place, as opposed to surface mount. Should be let's do a close-up here. If you're familiar with these from your kit, these are surface mount. And these are also actually just monocolor LEDs.
So when you say surface mount, you just mean you put the wire flat on it and weld it to the top of
Right. Yeah, when you're making surface mount electronics, you basically have these little pads that are basically the same as screen printing. You have a stencil and you apply the solder paste to that. And then there's a pick and place machine that sets components on it, and then it kind of melts it in a toaster oven. A little more advanced, but basically the same thing.
But I mean, for us, for soldering, we lay the wire on top or the tape on top, and then we solder it on top instead of sticking it through.
Oh, if you're doing surface mount?
Yeah.
Right. Yeah. You could also do that.
Surface mount then.
Yeah. We could do a whole thing on soldering techniques as well. But yeah, it's basically it's a little more fidgety, and you should have tweezers, but you can do surface mount manually. Through hole is usually a good way to learn. So, let's see. Cool. So there's all these different package types and colors. And you see basically what's happening with an LED is it's a diode, which is a one-way pipe for electricity. It flows from positive to negative through it. It will not flow backwards. And there's different types of diodes, not just light-emitting ones, which is what an LED is. It's a light-emitting diode. There's kinds that do power management. There's kinds that set a bias. It's all different kinds of things. The cool thing about these is as power passes through them, they happen to light up. And with these through-hole ones, you'll see that one lead is usually longer than the other. It might be kind of hard to see here, but you can kind of feel it out. Like one lead is longer than the other, and that will be the positive lead. So if you're connecting it to the positive side, and then the shorter side to the ground. And the other thing about diodes is they will eat up as much current. And voltage is basically how much push is going through the pipe, and current is how much power. So the issue with diodes, and light-emitting diodes especially, is they will eat up as much current as you give them. So with these, you need to use a resistor to kind of share that current load with it. And those are just simple components. And you can also see, if we can get it to focus in really close, we have the LED on each of these, and then you'll see right next to it is this tiny, it's probably easier to look on your own. Right next to each one is a little surface mount resistor. And now that I've told you that you absolutely need a resistor so you don't burn out your LED, I'm just going to go ahead and power these without one. The issue is these little coin cell batteries don't really have enough current to burn it out. You don't want to do it forever, but you know, here's a white one, which actually kind of looks purple through here. We've got some blue ones. These are a square package shape. These are the old style of RGB LEDs, which were totally cool at the time, and I haven't used them since because we have so many different simple packages. But these four-legged ones, I believe this longest one here is a common anode, and that would be the positive side. So anode is positive, cathode is negative. So with these type of LEDs, what you've got is you apply power to one of them, and as you apply ground to each of the others, you've got a red one, move that out of the way, and a green one, and a blue one. And if I just go ahead and mix these, you get like kind of cyan. I'll get my balance with the camera here. There's kind of an orange. And then they even have these that I found on AliExpress that are color changing. They actually have a little logic built in that it's easier to, we can talk about diffusion later, but here's the idea. It just shifts through color slowly. So these are all super cheap to find, usually in quantity, and it's just as cheap to buy 100 of them as it is one. So beyond that, the new hotness here is the Neopixel, and that's what we have 10 of on this board. And aside from that, you also have these jewels in your kits. Now the fun thing about these, they're addressable, and they're actually the exact same thing as these strips. Not all of these strips, there's different types, and I can tell you which kind to get to keep it simple. They have different advantages. Some of them have a separate clock signal that keeps everything synced better, but these are WS2812s. This is my big secret. This is the big secret. You can get these on Amazon, you can get them on AliExpress for super, super cheap if you're willing to wait. Amazon, you can get them in a few days. So I kind of do both.
Thank you, because I got some really bad ones.
Yeah, that's what I do. I'm good at finding the cheap ones. So basically, Neopixels are branded by Adafruit, but they are WS2812s. So you can get them in those packages. You can get them in these. I have these Christmas light looking ones. And they all just work on the same protocol, which is built into the MakeCode software. And with these, you can get different densities and different, you see this one is kind of like wrapped in rubber. It's waterproofing, essentially. But you can get, for even cheaper, just these plain ones. You see the screen share there. And so you can get them, I believe it's 30 LEDs per foot or 45. I think there's different densities. I can't remember what all the numbers are, but you'll see them and kind of get an idea for how many you need for your project. If you want to do like an LED video screen, you want a high density. If you want something that you can diffuse, then you can go with the cheaper ones that are lower density, you know, spaced further apart. And another fun thing about these strips is these connectors in between. And you see just just like these packages, basically all that you need to run these is power, ground, and data. And with these strips, you can see between each LED, there's actually exposed copper where you can solder into each of these. So you can just take a pair of scissors and cut these to your length and wire them together. So you can use the adhesive on the back, make shapes, put some acrylic over it, and basically have a sculpture together.
The one that's covered with the rubber, how do you get to the copper? You just cut it and then slice it, whatever your source is.
You can, yeah, you can cut it. I mean, when you get the waterproofed ones like this, they also have one that's in between. I don't think I have any with me, but there's one where they just kind of apply a coating directly to it. It's like a medium amount of waterproofing. But when you get to these, you kind of generally decide your length. If not, you can just cut through this as well, and you probably want to take a glue gun and kind of seal the sides if you want to maintain some integrity against water. So we'll get to how to do those. And this is basically the reason why we call them RGB LEDs. They're red, green, and blue. And this is an additive color mixing theory. So if you take a few colored lights and shine them in the same place, you'll see that naturally when you mix blue and green, you get the cyan. When you mix red and blue, you get purple. It's a little different than mixing paints, or it's a little different than mixing colors on screen. But this is like the additive light mixing. So when you add all three of them together, you get something that approximates white to the human eye. And of course, there's different shades of white, and you can see what's going on in each of these Neopixels on the board, which are the same ones along these strips. We've got, this would have been an easier way to show you all the pinouts here, but. So basically what we've got are, each one of these has a microprocessor that lets it receive an address so that as your Circuit Playground Express sends out color information to each of these, they'll kind of know where they are in the chain. And then each one has a red, green, and blue, and it's also tiny that it's just right into that same element. So it all just looks like one LED.
So are you saying that we could use that to power the strips and control how they light up?
Yes.
That's awesome.
So not necessarily power, but we'll get to that.
Yeah, not power, but you can use it as a remote control.
Exactly, right.
Because the remote control that comes in the box never works.
Oh, I know. I know those ones. They just have the multicolor remotes, and they're very cheap. It's like a whole microcontroller just on a tiny little chip that has like a dollop of epoxy over it, so you don't know what kind of chip it is. Yeah, you can hack those sometimes, but a lot of the times it's not worth it. It's kind of just easier to get some WS2812s. So we're going to look at, and I have, this might be a little harder with those. I have some different LEDs if you want them, different through-hole ones. They're fun to experiment with, and I have a few resistors, so we can get to that later. But since these are the old style of LEDs, or the classic style, I want to start out with getting the Circuit Playground Express to turn these on and off. So if we go into Make Code, do New Project. There we go. So all we really need to make these work. Sorry, I'm switching back and forth on you so much. So all we really need to make a regular LED light up, and especially these, they have the resistors built in. So they're good to go. We don't need to add a resistor. All we need is a ground, and I'm going to use black for ground. When you're doing low voltage electronics, you're doing DC, which is like battery, or when you're like taking out of a power supply. explaining AC and DC as a whole thing. But black is the standard wire to use for ground. Don't go and rewire the electrical in your house with that in mind, or based on any of my advice, because it's the opposite there, but. And then red is the standard for power. So I'm just going to take black and connect it to one of the ground pins here. And I'm going to connect the 3.3 volt with the red. And then if you look on your LEDs closely, you may, it's always good to have a magnifying glass around for doing this sort of thing, especially with surface mount components like this. But each one of these has a plus and a minus on it. So we'll take the ground and connect it to the minus side. And then we'll take the positive, add it to this side. Super simple. I think the one on the other side is blue. I think there's just different colors all the way through these, so. Yeah, there's a blue one. Now you can keep these in place if you want, but I think it's more effective to just snap these off. I'm just going to go ahead and take. Oh, were they? Okay, cool. But since we're just dealing with the power pin, we're just borrowing power from this right now, so it's always going to be on if we're plugged in. So I'm going to take one of these, find my ground again, and we'll just connect that. And we're going to, yes. What's that?
They do not have USB ports.
Oh, yeah. Oh, that's right. Cool, okay. I forgot Macs don't have USB ports anymore.
Oh,
That's fun. You got yours, right? Yeah. There you go. That's right, cool. You got a hub. Is everybody else, you got a PC? You got yours? Okay. Alana, you got yours? Okay. Okay, cool. Is everybody good? Yep. Thanks. Ground goes to the negative. There's a little plus and minus on the bottom there. I heard some of the speaker sound from the thing. Your what?
My laptop, it has my converter in it. It's okay.
Oh, okay. Do you need the USB converter? I think we have one more. Oh, okay.
It's okay.
Sorry. Okay, so we don't even need the light input for this yet. We're just dealing directly with turning voltage on and off on an output pin. So I'm just going to throw you for a loop and go straight into advanced. We're going to hit pins. And you'll see we can directly manipulate each one of these input-output pins. So I think what we'll do is we'll take digital right, which would be output. And I'm just going to add that into our forever loop. And I guess A0 sounds good. We could do any of the output pins. So I'm going to connect A0 and take A0 and connect that to our positive pin. Not sure if this will come on or not yet. There we go. Cool.
So A0?
Mm-hmm. It can be whichever you choose, as long as you match up your wiring to it. And I'm going to go ahead and set that to high. And I'm going to hit download to the Circuit Playground Express, and it's on. Is everybody having an all right time with that so far?
Does anybody have like a cell phone charging tank that I could use?
Oh, I do, yeah.
Oh my God, let's see if we have time. I can use that instead of my computer.
Yeah.
Oh, nice.
I might need to borrow that later for
No worries.
proving a point about power, but yeah.
I just wanted to see if it works.
Yeah.
And it didn't. You need the mount adapter or a different adapter? The mount adapter. This one, right? The USB C, USB-C, USB. Yeah, but you're gonna have to download it, right? So.
Okay. Everybody having an all right time with getting the light on? Okay. We'll catch up.
Is everything open? Okay.
And then to double check it, if you want to just click the switch, we'll flip it to low, hit download again, it should turn off. And there we go. Cool.
I'm sorry, what's the, how do you get to this program again?
Yeah. Oh, to make code or?
Yeah,
Okay. Go to makecode.adafruit.com.
thank you.
Yeah.
I don't have things like that memorized.
I didn't have it memorized till this morning. It's like I should probably know it.
What does it say again? Adafruit.
Makecode.adafruit.com.
Okay, there it is.
And I'm using the Windows version here just because it has a little extra feature, but effectively it's mostly exactly the same.
So do the LEDs on this, they just have, if they're not, whatever, they're either on or off?
Right. You can use pulse width modulation to kind of dim them, but it's a hack. You're just turning it on and off very quickly so that it has the appearance of being dimmer. Pretty sure I can figure out how to do that in MakeCode, but I haven't tried it. There might be PWM in here. Yeah, pulse duration. But if we're doing dimming, we might as well just move it to the Neopixels. So. Okay, so now that we know how to turn it on and off, we can do something else with it. So we know how the forever loop works, right?
Yeah.
Just as long as it's running, it keeps running that loop. We're going to go into loops, and we're going to add a pause. And we'll set that to 500 milliseconds, just half a second. I'm going to right-click on the digital write pin, hit duplicate, and bring that back in after. And we'll set that one to low. And then I'll right-click and duplicate the pause. So now what we'll have is when it runs, it will turn on the pin, wait half a second, turn off the pin, wait half a second, turn it back on. So what we should have is a blinky.
I'm having trouble, I wasn't here for the Monday coding session.
Okay.
How
Yeah.
do I find this guy on my computer?
How do you find that?
Be able to download it on.
Okay, yeah, you can just hit X out of that. Okay, cool. And what are we looking for?
I don't know how to get the files onto here.
Oh, yeah, you hit
I don't know
download.
it's cool.
Yeah.
And then how do I know it's going onto this guy?
Should, yeah, hit, okay. Alana, do you know with the Macs how Yeah, okay. Thanks. I haven't tried this on a Mac yet, so we're all kind of learning here.
Okay, thank you.
Yeah.
Yeah, it's different from how it's easy. I know how to do everything on PC.
Let's see. Okay, so we're on voltage out, so that's always going to be on. What we want to do, did you set the A0?
Yeah.
Okay. Yeah, just go ahead and move this red clip over to that A0 pin next to it. Cool. There you go. Yeah.
Okay, one question for me.
Mm-hmm.
So, it's a visual thing.
Okay, yeah.
I'm supposed to drop, wait, so I drop this in where?
You
Usually
drop-
there's this thing that pops up.
Yeah. Where is it? Try unplugging and replugging the USB.
Okay, so download.
There it is. Yeah. Cool. Yeah, every once in a while the USB acts up. I'm not sure as much on the Mac, but I think this. It's not.
Did I not do it right?
Let's see, you're on A0 and ground. So let's have a look at that. Oh, it's set to low. Go ahead and click that and set it to high.
Okay, there.
You could just click, it doesn't drag, yeah. The interface is a little weird. You kind of get used to it. And hit download again.
I have to re-download it.
Yeah.
See, it doesn't pop that thing up again. Like it should.
Yeah. See if we can kind of get a process together from the Mac users.
So I have to keep plugging this in and unplugging it?
No, you should be able to just leave it plugged in.
Yeah, that thing disappears all the time, and then that's why I can't keep up and
So to keep from doing that, there's see the tiny button in the middle of domain 2? Yeah, so you just hit that tiny button, it'll reset, and then it'll show the drive again. We'll see. There you go, yeah. Yeah, so on the Macs, you may have to manually, there's a center button. You see that there's these two interaction buttons. But in the middle, there's a smaller separate button here. That's the reset. So if the drive isn't showing up on your Mac or your PC for that matter, you can hit that and it will kind of reset it and set it up as a drive again. So if you're having trouble uploading your program, you can give that a try.
So ground goes to the plus sign, right?
Yes. Oh, no. Ground goes to the negative sign.
Okay, that's why I had it, but it was not working, so
Yeah.
So, it's not working, so I wonder if I did something wrong. So, I'm gonna try again. It's a different one. Maybe it was the light. Okay, so the negative goes to the black, to ground. I would love for you to sit here. I need more help than the average person, because I'm blind too. Okay.
Yeah, the miniaturization of electronics is brutal for.
And then the red is this is A0 and it goes to
See the
plus
other side.
okay. And I've downloaded it. It's connected. So I can try again. Okay. So push the button. It's still got the programming from last time. It didn't come up.
To
Did come up actually.
yeah.
You press the button again.
Oh. I don't
Did
see
you move
it.
your alligator foot to AO rather
Phew.
than power?
And you just drag it through like a USB.
Yeah. Yeah, they kind of geared this towards Windows. It's one of those things where the native platform tends to work a little better. Oh, yeah. There we go. Cool.
I tried putting in a startle sound.
Now, if it sounds like a turn signal, I have no idea why it decides to make a sound when you change a pin from high to low. That might be something to Google, but for now, MakeCode seems to add a clicky sound to the speaker every time it switches something high or low. That's fun. So just for fun, I'm going to take another one. We've got more than one ground pin, so I've got plenty of room to grab another ground. And we'll just do the exact same thing. Set negative to the ground. And I'm going to go ahead and take A2 just to give it a little space. Set that to positive. And this will be a really easy addition. I'm just going to duplicate, move this up, and A2. Set that to low. I'll duplicate this again. Move it up to the second half of the loop, and I'll set that to high. And now what we should have is two alternating LEDs. And there we go. Cool.
Oh, I thought you said negative goes down. Yeah. This is a zero. What's the color? Right, but it's on a zero.
So that's a basic idea of how to interact with our analog LEDs, which is basically what I'll call the ones that aren't addressable. Yeah, clear this off. Yeah. With the Neopixels? So it really depends on how much voltage you're putting in reverse. If you look at like an LED data sheet, you'll kind of see like there's a maximum reverse voltage before it breaks down. So if you're doing like this 3.3 volts from a microcontroller, it'll probably just not work. If you put like 12, 15, 24 volts backwards, it'll probably do a little, little fire and smoke. It'll light up, but just briefly and also with fire. Okay, so that gives us an idea of how to do analog style. I'm just going to go ahead and, well, I'll keep the forever block, but I'm going to go ahead and delete that. I wish this had a click and drag to highlight. It's a little, I'm actually just going to zoom out and just drag this off the screen. There we go. So since this thing is equipped with 10 awesome Neopixels, I guess we should probably do something with them. That's a little too zoomed. So did any of you go over some of the show ring stuff in the other workshops? Okay, so we'll just kind of do a quick run of it. So you can pick your colors here and just click to select off the color wheel. And if you click this gray in the center, it'll just turn it off. And I'm just going to grab some random colors just for fun. There we go. If I hit download, get a nice little array of colors there. And if we want to do a pattern, we can again do the same sort of blinky thing. Going to add a pause. We'll set it to half a second. And then I'm just going to go ahead and I'll just grab the default ring. Moved it down there, but that's okay. We'll just drag this one in the middle. And now we should have a nice little half-second loop of changing patterns there. So the default brightness is actually pretty low. They're actually very bright LEDs on this board. This is relatively low for its total range, but it's actually great for battery power. So when you're thinking about doing wearables, you want to think about how much brightness you're putting in versus, you know, how much battery consumption you're getting out of it. So this is our forever loop. I'm going to go ahead and click on loops and bring in an on start. And that's kind of like, if you're familiar with coding, it's like the setup portion of it. So if you're looking at Arduino or processing, you have like a setup and then a main loop. So this is stuff that happens once when we power it on. I'm going to click light and set brightness, bring that in. So if you put set brightness in the loop, it's fine. It's just that every time it loops, which is, you know, thousands of times a second, it will set brightness, and that's just unnecessary because once you set it once, it's fine. So I'm just going to make this super straightforward. Just grab one ring out of here. And I'll add some color just to get an example. Cool. So the default brightness is 20, and if you click on the number here, you get a little slider and go all the way up to 255. And I'm just going to go ahead and see how fast it blasts the camera. There we go. It gets a lot brighter. The point where if I want to do it on the camera, it's probably easier to diffuse it with something. There we go. Cool. And if you wanted to, you could do a dimmer blink like this at a pause. I'm doing this in a very sloppy way, but that's fine. So that would be a way to use it in a loop where you see we have dimmer colors and brighter colors. I actually want to bring my set brightness back. We'll make it a little bit brighter. Okay. That means it's working. Then we also have these, there's a couple different animations. So we can drag in show animation. And have we been through this? I'm not sure how far we went with LEDs, so. Okay, yeah. So there's a few different animations. You can just go ahead and set one of these in the forever loop. And you can actually see in the program as well, we've got the preview up here. So you see we're getting the same results out of that. And as it's in the forever loop, this time, it'll play for 500 milliseconds, but since it's just going in a loop, it will keep doing that perpetually. If we want to do like reactionary events, let's go ahead and add an input and say on shake. And I'm just going to go ahead and move my animation down here. And there's a bunch of different options. We can have this on tilt, have it on like free fall. These are different levels of gravity. So if you start like dropping it, to me that's like a drop alarm. And it goes up to 8 Gs, 8 times normal gravity, which really, I guess if you want to take this and swing it around, but I'm not really going to try that so much in here. So I assume it'll just go flying eventually. But you know what? I think that actually might be cool if you were doing something like poi or like, yeah, if you were to install this at the end of like spinning poi and put LEDs in it, that's probably what it's for, now that I'm thinking of it. So real-time learning, all right. So I'm going to leave this on shake for now. And we'll set that to 1 second. As I hit download, that animation should go off. Now if I shake it, cool. And now you'll see what happens is it's kind of stuck on the last frame of that animation. So it'll do that, but stick there. So the next part we need out of this is we'll just take light and scroll down to the bottom and there's clear. So we'll just add that to the end. So at the end of an animation, we want it to clear. And boom, there it goes. Where is my graph? I'm just going to go ahead and delete that block, and I'm going to go into Light and add a graph in here. Now, graph lets us take some input from a sensor and apply it to the light. And the basic one that everybody shows is we'll take sound level. So we can take these, this is live data, the kind of bubble pill-shaped ones here. So I can apply that to the graph. And if we hit download.
Where do you get graph from?
Graph is in Light. Yeah. So you see, each one of these I've noticed, I tested it with the two of mine. Each one of them has a little bit different of a microphone level. So from the easiest way to. So this one's a little loud, I think. So we can hit the plus here and have a little more control over it. I'll say graph sound level up to 100. It's kind of a guessing game with these because it looks to me like each mic is a little bit different. So I'll say graph to 100 and see how it changes. Now it seems like we're just way at the top of the scale. So I'm going to say 200 and see what that does. If you're not sure, try different numbers and see what it does, if it reacts differently. I'll just kind of tap on my, the ear on here is where the microphone is, so I'll tap on that. Or just hit the thing against the table, either way. But aside from sound level, we can actually do some different sensors on here. Yeah, sure. Sure, I might be like zooming through. I do tend to like zoom through and be like, this is all the stuff you can do. So pause me whenever you need to.
Yeah, really fast. It's okay.
It's a bit of an ADHD thing where I'm like, this is really cool, and I hyper focus and go all out. What's that?
For the animation one, where was the clear?
Oh, the animation clear, it's at the bottom of Light. So right there. Sorry, I'll make that readable.
Is there like a stop, like I could, to do something like on tilt, stop everything?
On what?
On like tilt or on something to stop everything? Is there a stop?
Yeah, you could have it clear there, but then it'll come back as it returns to the loop.
Yeah, I've got like a thing calling functions when something happens, but. Can you slide your screen over so we can see what I'm catching up? Download what you did. Oh, you haven't used it yet?
What's that?
I was just wondering, your brain, you haven't used it yet, so.
Oh yeah,
I
it's,
was trying to catch it. I'm caught up now.
yeah. It's not active right now, it's just hanging out. Oh, is it doing the turn signal thing? I think that's just part of make code. It's like, oh, we're changing a pin. Let's add a sound to it. You'd probably have to switch to the JavaScript to, although it mostly, when you switch to the code, it mostly shows in functions, so you might have to like dig down even deeper to figure out how that happens. Cool. All right. So my favorite input, if we click on inputs, we scroll down here, there's rotation, pitch. You can switch this to roll. They're both the accelerometer. So if we throw that into here, and try it in the simulator, see if that works. There we go. Yeah, so as we change angles, it should add like that. So I'm going to say, whoop, can't drag anything in here. I'm going to say 180 just because we're thinking in degrees. That might not give us quite what we want. I'll just download it and try it with the actual thing and see how we do. Yeah, so we have some degree of, this will be fun. Angle and keeping camera. Oh, this way, there we go. Okay, so that gives us somewhat what we want, but we kind of want the whole ring, right? This only works in the Windows app, but I'm going to go ahead and click on the Show Console Device. And this should give us, as I turn it from one side to another, you see the range of numbers. And we can see up here in the graph, saying the top is 83 and the bottom is -87. So as I turn it back and forth, that's what we're getting. So I'm going to use something called a map to kind of get us in the range that we want to be in. And again, that doesn't work on the browser or the Mac version. It just works on the Windows client. But kind of is what it is. Again, you can guess numbers. And since we're looking at pitch, rotation, and degrees, we can kind of get an idea of how to guess. So what I'm going to do is go into Math and bring in a map. I'll just go ahead and drop it in the graph. So what map does is take an input and it maps it from the original range of the input to the output range that you want it. So what I'm going to do is, in this first field, this is what's going to be mapped. So I'm going to put my rotation in there. And what we were seeing was, we'll say -80 to 80. And then on the other side, I'm not sure what the actual range of the graph is, but I'll say 255. So if you see 255 a lot, that's because it's the size of a byte. That would be 8 bits. So if you're looking at, this is fun, we can get into binary. If you're looking at 8 bits, basically the numbers double. It's called 2's complement. So if you're counting in binary, it goes 1, 2, 4, 8, 16, 32, 64, 128, 256. And because 0 is part of that range, it goes 0 to 255. So when you see like colors, like website colors, they'll be in hexadecimal, but that's basically 1 byte for red, 1 byte for green, 1 byte for blue. So when you see ranges that are 0 to 255, that's what's happening there. So I'm going to try this with that range, and that looks kind of cool in the simulation, so we'll try it. Nice. So my 180-degree turn, we were getting a full ring to nothing. Awesome. And mapping, takes a little bit of messing around with to get right, but that's the fun of it. You can mess around with this all day. Let's see. And I'll give you a minute to test that out. Does it help if I zoom in a little here? I'm not sure. How far away? Boy, that might be just out. There we go.
I think you did something wrong.
Who did?
So I had map rotation,
Mm-hmm.
and then when you added in the graph and then it disappeared.
You didn't have rotation. You had
Okay.
Mm-hmm.
Can you walk through the purple map function? I'm not really,
The map function?
yeah, I'm
Okay.
not really clear on it.
Yeah. I may have raced through that one, totally. So map function has 5 arguments, if we're starting back from the beginning. So this first one, map, asks you which input you want to map. So we'll use this rotation input. And then these next 2 are low to high from. So if we're getting, say, 0 to 255 from our sensor, we would say 0 to 255. And if we wanted to feed that to something that's expecting like 0 to 100, then we would just say from 0 to 255 to 0 to 100. So it basically takes your original range and compresses or expands it to a different range that's more appropriate for your output. So like this, we're doing 80 degrees this way to 80 degrees this way. And we want to turn that to 0 to 255, which is the total range of our LED rings. And I promise that's probably as much math as I'm doing. Luckily, it abstracts it away for you, and you don't actually have to do like scaling math, because that's a bit more of a pain to code.
You were saying it's only on the PCs that we can use the live kind of.
Yeah, the live, unfortunately,
It won't translate to my actual.
right. What I think you can do is use the console simulator.
Yeah, it doesn't work for like
I assume that that does not work as well, because you can do this, but this is a very limited form of interaction, especially for that sensor.
buttons work, but
Yeah. Yeah, I've noticed it's a little buggy doing the simulator sometimes, but
and that's what you have right there. Currently, you have the actual app downloaded onto your computer.
yes. Mhm.
I get numbers when I touch the, yeah, the picture. It gives me a graph. Oh, yeah.
Right. Especially with that tilt sensor, because what you're getting out of the tilt sensor here is like just kind of waving your mouse over it. I'm not sure how many degrees that actually is. It's showing like it's doing a 180, but it doesn't feel like that, so.
Like in this white box. So once I got it showing, I don't know what the numbers mean, but it is changing numbers.
Cool.
This?
Oh, is it doing it in the browser?
Yeah, in the browser.
Huh. Yeah.
I had to start, oh, maybe it's because my mouse is over that. No, so,
Huh.
so is the, what is this number? The degrees?
It
Oh, I was doing
might be.
pushback. I don't know, okay.
It may. I just know that the the browser input for it is not really, for security reasons, like web browsers don't usually allow access to the USB bus.
Oh, yeah.
So it kind of makes sense. Otherwise, you could just grab anybody's printer from your website, force it to print, So how's everyone doing on their tilty thing? Good. Tilty. Do you switch it to roll? Do you switch yours to roll? Or it does work that way, doesn't it? Yeah, that's on. Cool. How you doing? Oh, yeah, try hitting this little reset button here, see if that drops you back into the.
doing it because I missed some parts.
No, that should work all right. Hit close there. I think it's maybe just not re-downloading. Try hitting download again.
But it works with this one.
Hmm?
It works for this one, but
Mhm.
it didn't work for this one.
Yeah, you may have to just drag the new program to the drive to see if it's showing up as a drive on your desktop. Yeah, just move this window out of the way. Let's see.
It should be here.
Yeah, so go ahead and hit that reset button, and we'll see if it pops up as a drive. That's strange. Why does it think it's a network interface? Yeah, hit cancel. Shows up as, okay, now it's showing up as a drive at least, so we can drag the program over to it. There we go. Cool. Yeah, sometimes you just have to mess with the reset button. The troubleshooting, if you can't get the program onto it, would be hit the reset button. If that doesn't work, unplug the USB. And it's only happened to me once where I've had to close make code and reopen it. With the browser, you really shouldn't need to. So sometimes it just takes a little, shaking the cable to get it to work. Cool. So we can drag this out of the way. It's kind of cool part is we could actually just kind of keep this stuff out here. So I'm hitting control and scrolling to kind of zoom in and out. You can also, I think, plus minus, or you can use these magnifiers here. But I can just kind of move these off the active area of the screen and we can have them saved for later. And did we do any button input stuff with the other workshops? Did we do any button input stuff? I mean, this will be this is way simpler than map, so you could just have it. These live outside of the loop. They're kind of like on event handlers. So we can have our buttons, and we did some cap touch stuff yesterday, right? Capacitive touch with the soft keyboard, or maybe the day before. Right, trying to remember the schedule. But I'm just going to go ahead and use the little A and B button. And we'll leave our on start. We don't need anything in the loop. So I'm just going to say lights and show ring. Zoom out a little bit. So when button A is clicked, it shows this ring. I'm going to duplicate this button and say button B. And I will delete that ring. And we'll just put it clear on there. We'll see if I did that right. Yeah. Now if I hit the A button, we get a ring. If I hit the B button, it turns it off. So we got an on and off switch. Which is way simpler than a map function, but there it is. And we can also do that with, these pins are actually touch sensitive. They have capacitive touch. So I'll do that with, say, A2, and then we'll pick one on the other side. So let's see, A2 is right here, so let's just say A6. And hit download, and it'll do just the same, but with touch. And turn it on, turn it off. Where is 6? There, somewhere. There it is. Cool. And you can use your conductive thread. You can attach it to copper tape, aluminum foil, anything you like. Anybody ever have one of those lamps where you touch it, it changes brightness? Like my grandparents had that. They're super cool. I think I'm going to set up one of mine. I've got this old like copper lamp from the 20s. I need to rewire it with LEDs because it's all like soft braided 120 volt cord that I don't want to test. So we might make that have cap touch. That'd be fun. So are we good with button input? Everybody having a good time with that? So exciting, I know, on and off switch. We've approximated the light switch, but with capacitive touch. So let's see. So I think we'll do a little bit of logic here. Try to decide on that. Actually, let's not do that. We'll do a little for loop here. So what I'm going to do is go into loops and say for index from 0 to 4. We'll drag that in here. I'll put this in our loop. So what this does, it'll count up each instance from 0 to 4 and apply that operation to it. So we have 10 LEDs on the board. So I'm going to go ahead and say from 0 to 9. And then I'm going to click on light, and we'll grab a set pixel color. Might not want that one. Let me see. Yeah, there we go. Okay. Cool. All right, so we've got our for loop in here. I'm going to click on light and set pixel color at 0 to red. Now what I'm going to do is just keep this index, which will be the number that's being counted from 0 to 9. I'm just going to drag this over and copy it to set pixel color at index to red. Get rid of that extra one there. And you'll see that'll pretty much instantly just light up all of them. I'm going to go back into loop, hit pause. Give that, say, 200 milliseconds. You see now we've got a count up here. So what I'm going to do is go ahead and duplicate this whole thing and bring it underneath this first for loop. So the first for loop is going to go from 0 to 9 and turn each one red. And then the second one, I'll click on the red and we'll make it black, which will just turn it off. So that should give us a count up and then off, and it'll just keep looping like that. So we'll upload that. And this is how you keep from just, say copy and paste, turn this light on, turn this light off 10 times, or when you get to, what is this, 300 count? So instead of specifying 300 times that we should turn the LED on, this is programmatic thinking. And we can also just kind of drag this into the first one, delete the second loop, and I think that'll just give us one at a time. Yes. Cool. And now we've just got one at a time. Mm-hmm. Sorry? Right. That's how the loop works. Is it's basically, we're in our forever loop, and for is a loop within that loop. So it will start with, okay, index is 0. Turn this pixel on, wait 200 milliseconds, turn this pixel off. I could actually get rid of the second pause, so that work better, but that's okay. And once it reaches the end of that loop, it goes back and it adds one to the index. And then it says, and then that index will be pixel number 1, and then pixel number 2, and so on. And then that's how we get this pattern that counts up through them and loops back around to 0.
So if you had a strip of 20 lights, it would be 0 to 20?
0 to 19, yeah.
0 to 19.
But if you go out of range like that, 20 will just be a little blank 400 milliseconds as it sends it to something that's not there, or it'll error out one way or the other. We could try that, see what happens if I say 11.
Oh, because there's only that many outputs.
Hmm?
No.
Yeah, so it's just sending that data to nowhere in that case, but yeah. Yeah, indexing from 0 is good to keep in mind. The top of your range is -1 from where you think it is. If you got 20, then 0 through 19, we're counting 0. So that's still 20 individual digits.
Are these powerful enough to say, I have a strip of the LEDs, the little gems, attached to one of these, like A1,
Mhm.
and I want that to go on, and then
So-
and then I have another strip to another, is it powerful enough to do that?
So it's not powerful enough to do that by itself, but we can split out the power supply to that. And that's where I was going next.
Oh,
I was
okay,
going
never
to borrow this battery back, so we
nice
could do
segue.
something like this. Right? I love it. If people are asking the leading questions to my next section, I feel like maybe I'm going in order. It's hit or miss, but that's okay. It's good. So that would be the thing, is even though this controller, has the 5 volts, we have to think about how much current is going through it, and the fact that the wires that are inside, it's basically little copper traces, tiny, tiny, tiny copper traces inside the board that are carrying the voltage and the current. So current is basically a flow of electrons that's like a river current, right? I don't really want to use the water analogy because I'm going to get to heat, but so if you think about pushing a whole bunch of stuff through a tiny pipe, you get friction, right? And what does friction cause? Heat. Physics. So it applies exactly to electrons. So if you start pulling a ton of current through a very, very tiny line that's etched into a circuit board, you're going to burn it out, or the tiny lines that go through the chip. So what we want to do is add an external power source. And so you'll see with this, we actually have like a voltage out as well, and that bypasses the thinner chips. But you'd have to look up with the board how much current that can handle as well, because there's always a limit. If you look at power lines, those are much, much wider gauge than, this USB cable. But these are surprisingly power efficient, to the fact that I can run these 300 off this little solar battery pack, which is awesome. I actually let it run overnight, woke up, it was still on, and it hadn't exploded, so we'll see if it explodes today. Technically, it's a little close to the edge of the spec, but it seems to be working so far. So let's see, to that effect, I'm going to go ahead and get rid of this block. And now if you click on the light, we'll see that it actually adds another a little menu here for Neopixels. And that is going to be how we deal with externals. So keep in mind that, that these little jewels are exactly the same as each LED on this giant strip. So I don't have these to pass out, but if you have these, we can at least hook up 4 of them in series. And those actually, 4 of these will definitely run off this board. So we can use conductive thread. You can solder to the contacts. I think these are just big enough pads that we can hook alligator clips to it. Yeah, that'll be fine. So this kind of gets to like the implementation of how you want your project to come together. So you've got to consider your power source, how many LEDs you want, how it integrates with other things, and how you're going to wear it or how you're going to package it. I don't do a whole ton of wearables myself, but think about the medium as well, and then how much brightness you need, especially if you're going battery powered. Because you have things like this, which, see, this is not enough power for this room, but this cool little plastic diffusion thing. I've been messing with these. Let's see, I'm going to set my brightness up on this real quick, just for the sake of demonstration. Let's make this like bright blue. And just give me back my forever loop that I deleted. There we go. See if that's bright enough. That seems bright enough. I'm just going to set the brightness all the way up because we'll see. There we go. So these are little pieces of acrylic rod, very sketchy looking on their own, but the different sanding patterns. I think this one is just scored. You can see reflection of light. This one is sanded down smooth. Of course, harder to see in a bright room, but it's there we go. That's kind of cool. So thinking about different types of diffusion, and as you see me do like this, just to get it on the camera, to just cover it with paper. Not something you want to do if it's putting off a lot of heat, but it gives you an idea. Like staring directly at these all the time is a little trying after a while. Same reason we have lampshades. You ever stare at a light bulb and like, the lampshades are diffusion. There's all sorts of different ways to go about that. Also have, I don't think this shows up really well with the color, but there's different types of fiber optics that you can get. This is, this kind of side illuminates, and then there's ones that mostly show out the end that are more like data cable types, but yeah. Not really good for daylight, but this is an LED flashlight, so it counts. It's still LED. But yeah, stuff like this. Looks way, way better in the dark. I'm not super happy with it. I just got this off of Amazon. It was like $9. But, it's kind of fun for adding a little something. I think this would be really cool for wearables. You can just kind of, thread it through things, stitch it into place. Another kind of diffusion. I showed this in the Inkscape workshop because that's the exact other half of this, or is designing the pattern for it, but you can side light. Again, acrylic is like a lot of what I do. Things like that, as long as you don't torch it with the laser cutter and make it look ugly. But so especially when you're doing wearables, if you're doing them at eye level or anything like that, you might want to think about how it diffuses, or say you put it on the inside of a coat so you're getting the reflection off of the, the shirt that you're wearing underneath, as opposed to direct lighting. So that's kind of my aside into the practical parts of things. I'm going to try adding a whole bunch more lights to this. That'll be fun. So you can actually go and do, let's see, old news, old news, old news. This is actually a good guide on determining the power that you need. This is actually a really good guide. I'm just going to post this in the Discord afterwards. Instead of explaining everything about how to figure out how much wattage your, I do not want, I have my own light show. That's fine. Go away. This is actually a really good overall guide. So instead of explaining the wattage and all the math to you, head through this, and you can actually search LED strip calculators that will tell you, for a 5-volt strip, and these are 5-volt strips. You can get, the most common ones are 5 volts and 12 volts. I stick with 5 volt because these USB is also 5 volts. So if I want to battery power something, I can literally get a USB battery And one port is my Circuit Playground Express, the other port is my LED strip. It'll hold up for 8 hours.
So you just said that the LED is 5 watts?
5 volts.
Volts.
Yeah.
What number is the rubber coated one?
You can get those in 5 or 12. I think some of them have 24, but I would stick to 5. So here's a good idea of the density. Here's a good idea of doing an installation on, doing a nice little matrix. You can actually buy these in matrices too. Like Adafruit has like kind of a screen matrix and the driver to help you run that. So.
Cool, you could do your own bike, right?
Yeah, right. I'm going to do it on my rollerblades. That's my project right now. So I decided I'm too old to grind rails, so I'm just going to take the sides of my rollerblades and light them up. But yeah, here's an idea of other, I've got my USB battery. You can get a wall wart for up to 2 amps, and that's something you might recognize, The handy thing about these, you can go a couple different ways with this. I'd like to get these too. They're cheap on Amazon. They're just little adapter plugs that have screw terminals on the other side, and they come in both sides. So you can actually see that's how I'm powering this strip, is I can actually just plug this in. And you see, this is what I use for my my powered, plugged in version, is I have this USB breakout that has, I don't know, something like 80 watts or something crazy like that. 2.8 amps per port. And then I have an adapter to this, and that way I can just plug in and I have power. And all the same, I actually use this all the time anyways, USB to power jack, so I can do it with the battery as well. And again, these are like Amazon type things. Right. So what you see here on my strip is we actually have, and I'll get this little adapter port here. We actually have these 3 wires, and since I told you ground is black, of course this has to contradict me, and ground is white on these. The data is green and power is red, so those are our 3, just the same as we would do with these joules. And if you're not sure, you can look on the end of the strip, which is much easier to see in person. It'll actually say, it says plus 5 volts, DN for digital in and ground, so you can check against that. But what you'll see here is we also have these 2 breakouts for power and ground. So that's so we can power it externally. So we don't have to pull all that current through our Circuit Playground Express. I believe this is plugged in. Of course it's not. No. I was wrong. Not plugged in. Cool. So I'm going to flip back to make code, and we will set up something for ourselves here. I think I actually made note of this on here. WS2812, 10 feet, 30 LEDs per foot, so we have 300 count here. So I'm going to click light, and then we have this Neopixel option. So what we need to do first is tell the Circuit Playground Express that we have an LED strip hooked to it. So I'm going to put that right at the beginning of on start. It's easier if I look at my screen. So we're going to set strip to create strip on A1, so that's fine. I'll just connect it to A1 with 300 pixels in my case. Now, if you just want to connect all 4 of your joules, you can say create strip with 4, and then go that way with it. I'm not sure what to do with the brightness yet. We'll just set it somewhere in the middle. I'm going to go back and click our Neopixel, and let's say strip show animation. Cool. Now what I'm going to do over here is we've got our power supply. So I'm going to leave that unplugged for right now. I have this little, can we switch back to the, cool, thanks. I have this little breakout plug. This makes it a lot easier. Most of the strips that you order will actually come with this as a little JST header. It's just kind of the same as the power header for the battery pack on your board, but a 3-pin one. So I actually just use this breakout for it because this is easier to solder and we can connect and disconnect as needed. So I'm going to go ahead and connect that. Now we don't want to take the power from this board, right, because we don't have enough current to run this whole strip. So we want the data, but we also want the ground. So what you do is when you're using separate power sources, you want to connect the same ground because electricity is weird and kind of relative. So if you have two separate grounds, they could actually be at different levels of electrons moving around. So what you would get is kind of an erratic result. And I'll try to show it to you. Sometimes it's totally fine. But if you don't do it the right way and you forget the right way, it will not be fine when you need it to be fine, naturally. That is, which law is that? Not Moore's law. Something about things only going wrong when they really need to work. Murphy's law, that's the one. Very familiar with it. So what you want to do is you connect your two grounds so they have the same reference point, but we don't want the power connected. So I'm going to actually just unplug this for a second too. That's probably good practice. I've been doing this live. If you really want to be safe, I mean, these are pretty resilient. If you really want to be proper and safe, you should unplug things before connecting them together. So I'm going to go ahead and take our ground, connect that to a ground pin. And we said our strip was on A1. So I'll take the green one here to match up.
So the black one is not, or it's back.
The black one is going to ground.
Oh, I meant from the other.
From what?
The other end.
Oh, from the other one? Yeah, so what I have right now is, white is ground on the strip. But they are actually, these two are connected together at the solder point here. So let's see, A1. And we don't need to connect this power. You probably want to do something like wrap some electrical tape around it or, just bring it back here, keep it out of the way. I think that'll be fine. So we have both the connections we need there. I'm going to go ahead and plug this in. And I don't remember if we set the code to it, but we'll just download it again. Cool. All right, so those lights are off. This thing is theoretically already sending data, so we'll plug in the power and we'll see what we get. And there we go. Nice. Yeah. We can change our animation pattern. We can do this runner and see. It's kind of fun watching a 300 strip where you send it 1 pixel at a time. No, I guess this one's just crazy.
The video, when you look at it live, it looks different.
Shush. There we go.
Oh, that's the runner.
Yeah. Cameras aren't very good at picking up direct light sources. So you can see what else we've got for Neopixels.
If there are Neopixels that are just individual ones, when we're wiring these up, so I see the arrows are the data stream.
Right, oh yeah, I should have said that. Okay, so you've got, sometimes they say D in and D out. On something this small, they may just have an arrow for in and out. So what you want to do is go, and when you're doing connections, always think of output to input. It's the easiest way to keep track. If you're doing audio, it's the same thing. Guitar out to amplifier in. If the data is coming out of the board, out to in, and then chain these. So we would connect our power and ground, come out from the circuit express to the arrow pointing in towards the LED. and then out from there and into the next one. Yeah.
Does that mean that everything's being supplied through, that we are actually powering them through?
Yeah, well, I mean, you can power them through whatever you want because we have the separate plus and minus on these jewels. But in this case, you could totally power them from the Circuit Playground Express. This is just 4 more, and especially if you're not lighting up all the ones on the board, but I think it'll handle 4 more just fine. So I can pull back into this graph as well. And I think I still have that big map thing that I don't want to completely remake from scratch, right? Here we go. So you see my pulling back this graph piece. It's separate than this strip graph. But since we've got that same live data input right there, I can just steal the map from that. We'll try uploading that and see if it works. Well, there we go. Let's reset you. There we go. And try to download again. There it is. Cool. Now, oh, there we go. That's cool. As we're turning it, we've got, it's more fun if we just make a show out of it. Some good showmanship here. There we go. These are pretty resilient. Yeah, exactly. With these, they're flexible, but I wouldn't say in the sense that you want to fold them or you want to spend its whole life like moving it back and forth. If you have a moving part, you probably want to splice in and add some wire, preferably braided wire. But yeah, if you kink these too much, they will eventually fail. But they're pretty resilient. I haven't really had a problem with them. So there we go.
Can I make stripes on the side of a tracksuit?
Yes. Yeah, I mean, my thing is I just like wrap this around me. Like, yeah, there's no problem with that. I was just walking around my apartment the other night once I set these up with the battery, and I'm just like, I'm the holiday spirit in July. And these are so like compatible, I can just unplug this. Again, shouldn't do this live, but I'm going, oh, wait, I don't even need to do that part because we have, that's my white one. It's the nice thing about having these little compatible headers here. So I can unplug this. I can plug this one in the right way. And we can move our power over to this one. Cool. I'm not sure, I think this is 100 or, no, this is like 60? I forget. So we'd have to change our number on the setup, or else, it'll still light up, you just kind of get erratic information because it's sending to 300 addresses when there's only, I think this is 50 pieces. It'll probably make more sense. It'll probably seem more cohesive. Of course, it doesn't look like a straight line anyway, so it's, we're untangling Christmas lights. Yeah, maybe it's 100. Yeah, typical Christmas lights, right? But I like the longer strip better. That's. What's that?
Can you go over one more time with our individual lights?
Yeah.
How the power and data.
Yeah. So I could actually just break this down and give it a couple of these jewels instead of going with the big strip. Let's see, here's another one. strewn lights everywhere. There we go. Get rid of my power supply here. So let's just keep it on A1, and I'm going to go ahead and connect to the arrow pointing towards the LED. That'll be the input. And we'll take a blue one, take that to the output, and into the input of the next one. Now the part where it's going to get dicey is I need enough of these to power and ground both of them. Let's see, so we got our ground here, ground this one.
And you're going to the plus and minus, not the in and out?
Right, ground goes to minus and power goes to plus, so we'll be grabbing power off the board at V out, which is the voltage output. Or you could also use the 3.3 V, that'll be 3.3 volts. 3 1/3, that would be the number. So we got A1 for our data pin, and that's going into the first one, out of the first one, and into the second one. I'm going to use 3.3 volts. 5 might be a bit much for him. We'll see. Actually, 5 is fine for him. I am one alligator clip short here. So I've got kit under here. Yeah, you need to set the power to each one. Yeah. And that's where it's easier, you know, these are easier to kind of like solder with like a low gauge or high gauge wire, thin wire, and just kind of chain them together. There's a short one. To take another ground pin here. And attach that ground pin to our minus. And let's see if we can just kind of pop both of these on here. Try to get them to share a pad here. And we'll attach that to the plus from our 3.3 volts. And then we can leave that output empty. So then I'm going to set a strip with 2 pixels. And we'll just do something simple like set all pixels to red. We'll see if that works. No, you know, I actually have to plug this in too. That helps. So plug our Circuit Playground Express back in, and we'll download that. Okay, yeah, there's a showing. Oop. That's what happens if you don't have a stable ground on it. Start getting weird erratic signals. So we've got our 2 reds here. Oop, there we go. I think we might want these to be 5 volt and not 3.3. So I'm going to take them off there and put them on V out. Yeah, that's a little brighter. There we go. We've got a couple of red ones. They're not very bright, so with this you may need to set the brightness way up. And just for fun, let's make this something else. Show animation. There we go. So we've got that, and we can add that to I'll also put in the forever loop. We'll just do the same animation with the built-in LEDs. And we'll hope that it's non-blocking. But it isn't. Let's see. Yeah. Cool. Is everybody good with that, or can I come around and?
I couldn't find it, so I gave up.
I'm confused with
Yeah.
so it's got power going to each tiny thing and data going to each thing? And then,
The data chains through.
oh yeah, sorry, the
Yeah.
data changed through, so here to here,
I think
blue,
you got two on the, oh, you got your A1 and the power.
oh,
So you just want your power there. And the arrow pointing towards the LED is the input?
that's the data.
Yeah.
Oh, okay.
They are a little fidgety to work with the alligator clips. These are much easier to just kind of like solder in place with thin wire and attach to clothing. Which I think, something, oh well. Try one more thing. I'm trying to remember if this is the right way to go about it. You could set up multiple forever loops. And if you'll see right now on here, what's happening is the ring is playing the animation, and then these two are. You see they're kind of only going one at a time. So they're blocking code. So what's happening is that first action needs to finish first, and then it goes through the next animation. So I'm going to try setting two separate forever loops and see if that fixes it. I think there's something else to it here, but this might do it. Okay, cool. That did it. That's very intuitive. So now they're animating simultaneously. So sometimes instead of looping through multiple things, you want to set up a separate forever loop and have that happen, and they'll be simultaneous. Cool. I was hoping it wasn't more difficult than that. My showmanship has cost me a bunch of cleaning up. So we're getting cool. Awesome.
I think we've got, so you can just link them though, just from this positive to this positive to this positive, right? They don't have to go back to the,
Right, they don't have to go back to the initial positive. They just have to all be connected to that same power and ground. Mhm.
And that's in parallel?
that's series, it's in series.
The data is in series. The power, I guess, parallel, yeah. It's really like net, where anything that's connected to the same point on a circuit, despite where it connects, as long as they're, we would say they're like net ground. So anything attached to a ground, whether it's like out in a star configuration or in line, all nets to ground. So it's essentially the same. Until you get to more complex stuff like radio frequency and things like that, where you want to optimize. But for smaller projects like this, if everything's connected to the same ground somewhere, then it's all ground. So, yeah.
I couldn't really see what was going on up there to get it all set up. Could you help walk me
Yeah.
through that or us? 'Cause
No, I don't know how to wire it.
Yeah, okay.
Yeah,
So we've got our ground in minus here, right?
I think so.
So, mine too. Okay, yeah, I can't actually see the minus on this, but that one's plus, so by power of deduction. Oh, there it is. It's a little covered by the copper pad. Oop. I dropped it off the board. Yeah. Yeah.
didn't
Oh, I
wanna
see.
detach
I see.
from that
Yeah.
thing, so
Yeah, it's a cool
Probably
thing. I
not.
like it.
probably causing some of the trouble.
Okay, so A1 will be our data. So that's the arrow towards the LED. So we're going into the LED to tell it what to do.
Ah, okay.
And then we just need a power. So we'll take V out, which is voltage out,
Okay.
and apply that to the, not there, to the plus. Yeah, it is definitely fidgeting. There we go.
Okay.
It's a little hard at the angle. It's going to try to come undone. But yeah.
They're a little short, but I get it now. And then to do a second one, you said the data goes chains to the
Right,
next
so
one.
out and into the next one. Mhm. And then it automatically addresses itself in order, which is amazing. It's okay, me neither half the time. At least half the time.
No, that's not it. I'm just the most supportive of You missed like things. Hey, I know how to make the thing blink and play a pew pew sound. I have done it.
So you got everything you want
Yeah,
out
I
of it.
did a space laser last time, so whenever I went like that, it
Yeah, I mean, and also there's a whole recipe book, like beyond all this, just in general with make code. LED workshop. There you go. You know, this whole thing's just a recipe book, so feel free to scroll through that anytime. Oh, speaking of ways of diffusion, I saw this on here. I haven't seen anybody do that in a while, but using glue sticks. Super cool. It's the perfect amount of like diffusion. And you can actually, glue stick glue comes off stuff like this really easily, so you can actually just kind of hot glue it into place. Don't go overboard with hitting the heating element, but you can drip some glue around it and hold it in place, and it's fine. So,
I do have a question.
yeah.
So I couldn't find your code, like where you got your code from, because it was like on start, and then that's where I got stuck, because when I went for, you went so fast, and then I couldn't find one that said set, strip, and then what I needed here.
Oh, okay. So click on light, and then click on Neopixel. It'll be that sub-menu that comes up. It's kind of weird. But yeah, click light again.
Oh, okay, so you scroll down,
Click Neopixel. There we go.
that's where it was.
Yeah. So you want
I
to,
missed
yeah.
that part, and so I couldn't find
So we
it.
want that set strip 2.
Okay, so this one I don't need, this is the wrong one. So I was trying to copy, but every time I would go.
Right. Yeah. That's
You would
set all the
switch to
pixels to
something else,
color.
yeah.
Sorry. So yeah. So grab the beginning part of that and on start.
Okay. Thank you.
Yeah.
And then what did?
And then for
So
forever.
I can't copy it.
Yeah. So hit your light and Neopixel again. And then you can, any of these, you can set your animation. You can set them all to one color.
Okay.
Yeah.
Forever. Or up there.
In the loop. Oh, yeah. So click strip. It'll give you a drop down. Set it to strip 2 because that's what we've named it now. Cool. Yeah.
And like, just quickly, like, what does that mean? Flashing?
That one is like a comet. It does like a trail throughout it. Yeah.
And
You can
like some off and some on?
Yeah, one of them's sparkle, and you can actually get those same things for the built-in LEDs, just under light, and you can do the same thing with that animation.
Because I wanna set this up to be my remote for my track lighting.
Yeah.
Because I sent it back to Amazon, but I could buy more because I was like, these are stupid. The remote doesn't work.
Cool. Yeah. So I think we're good on the stream. Thanks.